Hi, my name is Kate Berry from the University of Texas at Austin. Welcome to this video on the UPS check squared attack strategy, which is the attack strategy that we use in the Pirate Math Equation Quest multi-step word problem intervention with total, difference, change, and equal group schema. As we walk through this presentation, I will demonstrate how we use our attack strategy to set up and solve single and multi-step word problems. Our Pirate Math Equation Quest multi-step word problem intervention has 5 components: Captain Cards, Equation Quest, Buccaneer Problems, Ship Shape Sorting, and our Jolly Roger Review. We see our UPS check squared attack strategy featured in our Buccaneer Problems and our Jolly Roger Review. We use the UPS check squared attack strategy in our Jolly Roger Review when students are setting up and solving the independent practice word problem, but mostly we see our UPS check squared attack strategy during our Buccaneer Problems, so that's the focus of this video, using our UPS check squared attack strategy within the context of the Buccaneer Problems. Now, when we're thinking about the materials that students will need for our UPS check squared attack strategy, we'll first need our poster here. Second, we'll need our Buccaneer problem worksheet. Third, once you've introduced total, difference, and change schemas, this What Do You Ask Yourself poster is really helpful for students because the questioning and the gesturing helps them to distinguish among the problem types. And lastly, we will have our pencil. So here, when we're thinking about an attack strategy, it's really an important research-validated strategy that helps students work through a word problem. An attack strategy is just a generalized process for setting up and solving a word problem, and it's really helpful for students to be able to go through a set of steps. A lot of attack strategies have mnemonic devices. Ours is UPS check squared, but you can choose to use any attack strategy with which your students are familiar, as long as number 1, the first step is to read the problem, and number 2, you're using the exact same attack strategy with students every day. So I'm going to walk you through the steps of our attack strategy, UPS check squared. First, students will check for a table or a graph. If they see a table or a graph, they will number it. Then they will understand by reading and underline the label. Sometimes during underline the label, students will check for irrelevant information, but they also can check for irrelevant information during our first P, which is when we're going to put parentheses around needed numbers or numbers that are related to our label. After we put parentheses around our needed numbers, we're going to put our numbers in order. In our multi-step word problem intervention, we have some word problems that have 1 step and some that have 2 and even 3 steps. Here, what we will do is put a 1 above any needed numbers involved in the first step of solving the problem. And when we have multi-step word problems, we'll put a 2 and even a 3 above the numbers involved in the second and third steps of solving the problem. After students complete the first 2 U's, the first 2 P's, they move on to our S. Our first S stands for schemas. Here is where students will determine if we have the total, difference, change, or equal group schema. Students will write the letter to indicate which schema the problem is, to which the schema the problem is referring. And then students also will solve the problem. After students complete the schema and solve steps, they then will check their answer for reasonableness. First, they will check their number answer, and then they will check their label answer to make sure it matches what they underline in the first step of U. So this is our UPS check squared attack strategy poster that students will walk through as they set up and solve word problems. So let's do just that. Let me grab my marker and we'll work through this word problem together. Here, we check for a table or a graph. We don't see one. If we did, we would number it. So I'm going to read my problem after I write my steps. U, U, P, P, S, S, check, check. Here it says, Linda bought 56 curly bones and green shoes for her dog Rosie. If there were 19 green shoes, how many curly bones did Linda buy? So I've read my problem. I've also checked to see if there's a table or a graph. There's not, so we know we're good to go. My next step is to underline my label. I'm going to find that in my question sentence. It says, how many curly bones did Linda buy? Here we're talking about curly bones. So I'm going to go ahead and underline that. Check off my U. If I wanted to check for irrelevant information during this step, I could. I also could wait until I get to my first P, which is parentheses needed numbers. So I'm going to scan our numbers and make sure all of our numbers are talking about or related to curly bones. Our first number is 56. That's about curly bones. So I'm going to put that in parentheses. Oop, but it's not just about curly bones. This is about curly bones and green shoes. My mom's dog loves those green shoes, so we can't forget about that. Then our next number is 19. That's about green shoes. Well, that's not talking about curly bones, but it's related to curly bones because we're talking about dog treats. So I'm going to put that in parentheses. Now I have put my numbers in parentheses, so I can check off that first P. Here I only have 2 numbers, so I know I'm working with a single step problem. So I'm going to put a 1 above my first number and a 1 above my next number to let me know I have 1 step for solving this problem. Checked off my first P. My first S stands for schemas, and this is when we can look at our What Do You Ask Yourself poster to work through and figure out what kind of problem this is. So let's read it again and look at our What Do You Ask Yourself poster. This says Linda bought 56 curly bones and green shoes for her dog Rosie. If there were 19 green shoes, how many curly bones did Linda buy? So we can say our parts put together for a total. Are 2 amounts compared for a difference? Is there a starting amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? Well, here I know I have curly bones and green shoes, and I'm putting those parts together for a total. I know this is a total problem, and we said it was a single step total problem. So I'm going to put a 1 to let me know it's 1 step and a T for total problem. So I'm going to check off that S. My next step is to solve. Here we can have students use the large schema mat, version 1, 2, 3, 4. All of them have the total schema on them. Here I'm going to assume that the student already has mastered and understood the total steps and that we know them. So we're going to write P1 plus P2 is the same as T. Now I find my total. I know my total. 56 is not just talking about curly bones. 56 is not just talking about green shoes. It's talking about curly bones and green shoes. So I know my total. My total is 56. I'm going to put that under the T. Check it off. Now I need to find parts 1 and parts 2. Part 1 is green shoes. So I'm going to put 19. Now part 2 is curly bones. I don't know how many curly bones I have. That's what I'm looking for, so I'll put a blank. Now I'm going to add my signs. Now because I have a total problem with a missing part, I know that I need to subtract. So I'm going to do 56 minus 19. Draw my line in between our 1s and 10s column, circle our sign. 6 minus 9, I can't do that. I need to regroup. 16 minus 9 is 7. 4 minus 1 is 3. I know my number answer is 37, but I'm not finished. Every number needs a label. I like to draw a blank to help students remember that they need a label next to their number. And I can see what I underlined was curly bones. So I'm going to write curly bones as my label, and I've solved it. Now the very last thing I need to do is check for reasonableness. I need to check my number answer and my label answer to make sure they make sense. So here I could do 37 plus 19. That gives me 56, so I know that my number answer makes sense. Many different ways to check our number answer for reasonableness. And then I need to check my label. Curly bones matches what I underlined, so we've solved this problem. So you can see here how we've gone through the UPS check squared steps and how they really aid students in following these set of steps to set up and solve the word problems. Let's look at one more example. Now let's look at another word problem and see how we would work through it using our UPS check squared attack strategy. Here we see I have my poster, my What Do You Ask Yourself poster, so I'm ready to get started. The first thing we always want to do before we even read through our steps is check for a table or a graph. Here I actually have a table or a graph. This is a pictograph, and the key says each flower stands for 10 flowers. So I'm going to go ahead and number this. So we have daisies, 10, 20, 30, 40. So I'm going to write 40 over here. Then we have roses, 10, 20, 30, 40, 50, 60. Then we have tulips, 10, 20, 30, 40, 50. And I'm actually going to take a second and scoot this 40 over so that it is not cut off by our graph. So thank you for your patience while we put our 40 there. Much better, easier to see. Now that we've numbered our graph, I can write my UPS check squared attack strategy letters to help guide me through the problem. So our first U stands for understand by reading. This says Mitchell picked flowers from a field. The pictograph shows how many of each type of flower he picked. How many more roses than daisies did Mitchell pick? So I've underlined my label. I'm going to check it off. Now I've understood by reading rather, I'm going to check it off. I'm getting a step ahead. Woo! Now I'm going to underline my label. I can look at my question sentence. How many more roses than daisies did Mitchell pick? The question is asking me about roses. It says how many more roses. So I'm going to underline roses. I've underlined my label, I've understood by reading. I'm ready to move to my first P, which stands for put our numbers in order. Now, I don't have any numbers in my word problem story, so we always tell students that we need to look in our story and in our graph or table for needed information. Here, I have my first number. This is about daisies. Here my question sentence says how many more roses than daisies. Well, I know that's going to be important. We care about the daisies. Our next number, roses. We know we underline roses, so that's going to be important. So I'm going to put a check mark next to that. Our last number is 50. 50 is talking about tulips. But our problem isn't about tulips. So here we have irrelevant information. I'm going to cross this out. You might not be able to see this on the board, but we're going to cross out tulips. So here you can see in my first P, I chose to use it as an opportunity to cross out the irrelevant information. Check off that first P. Move to my second P, which is put the numbers in order. Here, we know we have roses and daisies, and we have two numbers, and we're comparing those two numbers. So here, because I only have two numbers, I know this is going to be a single-step problem. So I'm going to put a 1 above my 40 daisies and a 1 above my 60 roses. I'm going to check off my P. Now I'm going to move to my S. Again, I'm going to assume that students have understood and know all the steps for total, difference, change, and equal groups. Here, let's read the problem again and work through our what do you ask yourself poster to see if we can figure out what kind of problem this is. It says Mitchell picked flowers from a field. The pictograph shows how many of each type of flower he picked. How many more roses than daisies did Mitchell pick? Here we have roses and daisies, and we're comparing those two amounts. When we have two amounts that we're comparing for a difference, we know that when it's a comparison, it's a difference problem. So I'm going to put a 1-D, and I'm going to circle that to help me remember to stay organized. That's going to let me know it's a single step problem and my schema is difference. So I'm going to check that off. Now I'm going to write my difference equation. G minus L is the same as D. The greater amount minus the lesser amount is the same as the difference. Now, my second step when we have our difference poster is to bracket our compare sentence, which has our compare word, and label the greater and lesser amounts. Here my compare sentence is how many more roses than daisies did Mitchell pick? So I'm going to put brackets around that. Whoop. And I'm going to label the G and the L. We always want to label the G and the L above our words and not our numbers. Here, we're comparing roses and daisies. And it says how many more roses. So roses is going to be our amount that's greater. And then daisies is going to be our amount that's less. Now that I have written my difference equation and bracketed my compare sentence, I can move on. My next step is to find the difference. I don't know the difference. It says how many more roses than daisies. It's asking me for the difference, so I'm going to put a blank underneath my D. Then I can fill in my numbers for G and L. We said the greater amount was roses. I have 60 roses. I'm going to check that number off here. And my lesser amount is daisies, and I have 40 daisies. I'm going to check that off here. add my signs, and we can subtract. A lot of students can do the mental math. Great. If they can't, they can line it up. But here I know that my difference is 20. I have my number answer, but I cannot leave my number hanging. I need my label, and we underlined roses. Here, I've checked that. Here, I now need to check my number and label answer for reasonableness. We can check this multiple ways, but I know that 20 plus 40 is going to give me 60, and 60 minus 20 gives me 40, so I know that my number answer makes sense, my difference makes sense. I'm going to check that off. My label answer is roses. That matches what I underline, so I can check that off too. So here's another example of how we can use our UPS check squared attack strategy to work through a difference problem and to work through a problem with a graph. So again, this UPS check squared attack strategy is just a generalized process that's going to help students work through a word problem step by step. So here is an example of student work. Here you can see that the student used UPS check squared to set up and solve the problem. We see the student underline the label, crossed out irrelevant information, put parentheses around needed numbers, put the numbers in order, wrote the equation, solved for the missing difference, and wrote the number and label answer. So this is what we want to see. This is what we want to see when students are setting up and solving word problems. Let's take a look at a student and tutor or teacher in action as they set up and solve a word problem using our UPS check squared attack strategy.
All right, Rose, we're going to do problem B. Do you see a table or graph?
No.
Nope, so what do we write?
U, P, F, F, J.
Awesome, what's our first step?
I understand by reading.
All right, let's read it. Rad planted 465 flowers in his garden. Joanne planted 328 flowers in her garden. Scott planted 99 flowers in his garden. How many fewer flowers did Joanne plant than Rad? A way to check off your step. What do we do now?
Underline the label.
What's our label? What are they asking about?
Plants. Red plant.
Let's look at that question. Yeah, it says how many fewer flowers did Joanne plant than Rad? Awesome. Check off your U. And I also saw a word in there that might help us later on.
I know what it is.
What? What is it?
It's fewer.
More, fewer, less, ER. What does that fewer tell us?
It's gonna have a difference in there.
It's definitely going to have a difference in schema. Good job. All right, let's go to our P. What's our first P stand for?
Okay, parentheses needs a number.
So any numbers related to flowers, but let's be careful. We're talking about fewer flowers did Joanne plant and Rad. So we're talking about flowers that Joanne and Rad planted. So let's read through the problem.
Okay.
Rad planted
465 flowers.
Very good. Do we need that number?
Yes.
Yes, because it's related to Rad and flowers. Let's read the next sentence. Joanne planted
328 flowers. And we don't need Scott's flowers.
Why not?
Because we don't. They're saying how many fewer flowers did Joanne plant than Rad?
So they're not asking about Scott, are they?
Nope.
They gave us what?
Just
An extra number, right?
Yeah.
That we don't need. They're not asking about Scott. So what do we do to a number that we don't need?
Cross it out.
We cross that out so we don't get confused and we don't accidentally use it. Nice job, Rose. Did you finish that step? Now what do we do?
Put the numbers in order.
How many numbers do we have in this problem?
2.
2, which means it has to be what?
A one-step
A one-step problem. Awesome job. Check off your P. And I think you already figured out the schema even.
It's different.
Yeah, and how do you know that again?
Because it says few.
And we know that more, fewer, less, ER words tell us it's a difference problem. Good job, Rose. Check off your schema. Now we gotta solve. So what's our difference equation?
This is the greater, and this is the
Good job, Rose. So I saw you labeled G and L, but we also need to bracket our compare sentence. Where's that compare word that you pointed out? Fewer. Yep, so let's put a bracket around the beginning and a bracket around the end. Nice job, Rosie. All right, now what do we do? Find
the D.
Do we know the difference?
Nope.
Nope, they're asking about the difference. So what do you put under D? Beautiful. Now what do we find?
Now we have the.
Nice. And after you write your numbers, what do you do up here?
We check them off.
All right, you probably can't do that in your hand, so what should we do?
We should stack it.
Let's stack them and do the standard algorithm. Why don't we draw the line and circle the sign?
Oh yeah.
Yeah. Beautiful.
9, 10, 11, 12, 13, 14, 15. That's 7.
Nice job. What do you count up?
Okay, now that equals 3. And that's a 1.
You're doing great. Keep going.
Oh, okay.
Looking good. You're doing great, Rose. Nice job, you solved it. All right, what do we do now?
We have to check the number answer.
Yes, how do you check your number answer for a difference problem?
The proud D.
Proud D, what? Grumpy?
Grumpy G has to be greater than everything.
Yes, so is it?
Yeah.
Is 465 greater than 328?
Yes.
Is it greater than 137?
Yes.
Awesome, your numbers make sense. And let's make sure we write our 7 the right way. That kind of looks like an F.
Oh yeah, it does.
There we go. All right, check your label answer.
Okay.
Does it match what you underlined?
Yes.
Awesome, let's read the problem.
How many fewer flowers did Joanne plant than Ryan?
137
Flowers.
fewer flowers. Let's put a little caret and write fewer too.
Let's put a 0 and
Fewer. Awesome job, Rose.
Thank you so much for taking this time to watch our UPS Check Squared attack strategy video featured in our Pirate Math Equation Quest multi-step word problem intervention with total, difference, change, and equal group schemas. I'd like to take a second to thank the Institute of Education Sciences, Texas Education, and the Meadows Center for Preventing Educational Risk. Without their support, this research would not be possible. Thanks for watching.